All right, hello. So today, what we're going to talk about in this video is about solution sets to inequalities with two variables while graphing. Okay, so for your title, you want to make sure that you title this Unit 3, Lesson 17, Solution Sets to Inequalities with Two Variables, Graphing. And in this video, you should be able to graph a linear inequality from slope-intercept form, as well as you can rearrange a linear inequality from standard form to graph the linear inequality. Okay, so here we go. We have example 1. It says, graph the solution set of the inequality negative x plus 8y is less than negative 24, right? So what we've done before is that remembering that less than, this is less than, and then we have greater than, right? And the way we showed this on a line is through an open circle, remembering that? Open circle. And then we also have less than or equal to or greater than or equal to. So this is less than or equal to, and this is greater than or equal to. And then we also realize that that's where you do a closed circle, for instance, closed circles. Okay, so this just means that we don't include the solution that is received at the very end. So that's why it's open circle. But here we do include that solution. That's why it's closed. Now, when we're graphing an inequality with two variables, this is where it gets a little different. We can't just easily use these symbols in math anymore. Okay, so there's a different way in showing that in graphing two variables, right? So we're going to do this first. And our first step is, if we notice that this negative x plus 8y is less than negative 24, this is in standard form, and we can't necessarily graph our inequality line in this form. So your first step here is going to be to change standard form to slope intercept form. Okay, so I'm going to go ahead and do that here in this bright blue. So I'm going to zoom in a little bit. Okay, so here we go. This is our first step. So we have negative x plus 8y is less than negative 24. Okay, so I'm going to isolate my variable and changing this to slope-intercept form by isolating my y variable. So I'm going to add x to both sides. Okay, so that's what I did right here. Add x to both sides. And then I'll get 8y is less than x minus 24. And then I'm going to divide by 8 to each of these. Okay, so that's what I did here. Divide by 8, divide by 8, divide by 8. And then I get y is less than 8x minus 3. Okay, so this is my new inequality. So this is the same representation, but in slope-intercept form. So I'm going to write that right below here. So y is less than 1/8 x minus 3. Okay, once we are done doing this, the key thing whenever graphing, it's always best to graph its linear version first, and then be able to graph the inequality. So I'm going to mark this in gray so that way we can see that. And it's not going to be my final answer, but it's going to help us to determine how it could look like. So right here, sort of step 2 is going to be identify and graph the linear equation. And I'm going to put here, this is temporary. Okay, so I'm going to mark this in gray so that way you all can see that. So essentially, if we were to write this is an inequality. If I were to write the equation version of this, the linear equation, it would be y equals 1/8x minus 3. Okay, so here I'm going to graph this. And so from this point, I know that this is my slope, and this is the y-intercept. And that's all I need to start graphing. So I find my y-intercept on my graph here. So I find -3, 1, 2, 3. Here's -3. And then I go ahead and start graphing my slope. So I rise 1 and run 8. So 1, 2, 3, 4, 5, 6, 7, 8. So here's my first point here. And then my second point, I can't go any further off. I'll be off the chart. So I'm going to go the opposite direction. So I'm going to go down 1 and rise 8. So, or rise 1 and then run 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, at this point, my line, I'm going to try to do this as best as I can. This is going to look really, really bad, but okay. Oh my God, it's happening. Okay, so essentially the line, the linear version of this, the linear equation y equals 1/8x minus 3 would look like this. Now, it's in gray because it's not going to be our inequality, right? But it's a good starting point for us to see how to create this, okay? So for step 3, what we need to do is identify and graph the inequality equation. And essentially, the only thing that's going to be really different for this is that we have to look at our sign, look at our inequality sign, and then we also need to determine how to draw that. Okay, so a key thing here is making sure that we look at our sign. Look at sign. I'm going to explain why that's important. Now, I'm going to do this in blue so you all can see this. So right here it says less than. Y has to be less than 1/8x minus 3. So what this means is our inequality is not going to be a line, okay? Because the line means when it's shaded in through all the line, it means we're including all of these solutions that this line creates. Just like we would say here, less than or equal to, we put a circle dot because we know that includes that solution. But in this case, it does not because it is less than. Okay, so the way we show this inequality is, notice here, I'm gonna if I can go ahead and do this, I'm just gonna make, oh no, that's not what I wanted to do. Okay, well great. Let's see. I'll just go ahead and do this one more time. Okay, so what you're going to do is instead of creating a full line because it's less than, instead we have to draw a dash through the line. Little dash marks. So it's going in the same direction of our linear equation, but notice the dash marks. This just means that I'm not going to include all of the solutions here. It just means that's kind of like my boundary. So finally, if I were to eventually erase this, my line would look something like this, okay? So what this means now, we have to actually identify the solution set. And the way we do that is by there's many ways that we could do that, but here, if we know that when x is 1, for instance, on this graph, we want to find all the values that are less than that. So our y value should be less than that. So in this case, if we were to start a point here, it would go straight below. So it would go straight, oh God, it would go straight below. Let me try this one more time. So if I were to have a point here, it would go directly down. And the same thing here. If x were 2, for instance, in this case, if I were to substitute 2 in for my inequality here, then my y value, I expect for it to be less than that. So it's going to go down below. And essentially, you would do the same thing for each of these. You want your y values to be less because that's what it tells us here. Y is less than 1/8 x minus 3. And you could go ahead and do that. And what you'll notice is, from this point, if you were to keep going, it had to include all of these values right below the inequality. Okay, so when you are doing this in your notebook, you can shade in all of this. And I can do this like in orange so you can see this. So like everything right below this will be shaded in, right? So I can just include like all of these values below this dashed line, but not including those points on this dashed line will be included, okay? So one way that you can check this, is to test a point. Right? So if you're not sure and you're like, you know what, I didn't quite understand that, I'm going to like test a point if you're not sure. Test a point. So here's our inequality. Y is less than 1/8 x minus 3, for instance. Okay, so I'm going to test the point 0, 0, right? So 0, 0 is right here at the origin, so it should not work. Okay, if I shade it in the right direction, it shouldn't work because I'm saying that all the solutions work less than this inequality line. So if I were to substitute 0 is less than 1/8 times 0 minus 3, well, 0 is less than, well, we get 0, negative 3. Is this true? Is 0 less than negative 3? No, that's false. So that's my clue to say, oh yeah, I did test this right. I didn't shade on the other side because if I shaded on the other side, I'm saying 0, 0 could be a solution and it's not, right? So that's one way you can test a point and check, okay? All right, so with that, I'm going to go ahead and do a next problem. I'm going to do this one a little bit more quickly, but just following our steps here. So I'm going to see if I can drag these with me. Okay. All right. So I'm going to bring these down with me over here. Okay. All right. So for this part, we're going to do the same thing. We're going to change this to slope-intercept form. So eventually this will become negative 5y is less than or equal to negative 8 plus 15. Divide by negative 5 on both sides. Y is less than or equal to 8/5 x minus 3, okay? And so our second step is to identify the temporary equation. So this is essentially y is equal to 8/5 x minus 3. Remember, this is not your final equation. This is just you graphing it so you can get an idea how it should look like. So we find negative 3. Here's negative 3, and we rise 8. 1, 2, 3, 4, 5, 6, 7, 8, and run 5. 1, 2, 3, 4, 5. And then down below, rise 8 by going down. 1, 2, 3, 4, 5, 6, 7, 8. And then we're 1, 2, 3, 4, 5, 6, 5. Here we go. So my point should be somewhere like right there. And so then our linear equation of this looks somewhat like this. Okay, so remember, this is just the temporary one because we're graphing inequalities, not lines. Okay, but what's interesting about this, and we look back, so identify the graph and inequality of the equation, so look at the sign. So this is y. Oh, key thing about this, I forgot to do this. Okay, So here, recall when we divide by negative, we have to change this sign, right? So right here, you want to make sure that this changes, so it becomes y is greater than or equal to 8/5 x minus 3. Okay, so that's our new equation. But you can still graph the line as is, right? So notice that even though our sign changed, it still is equal to. So what this means is we can, instead of doing the little dashed mark, we can go ahead and actually include all of these solutions that the line touches. So that's going to be part of our line. But now we have to see whether or not, are we going to shade in over here to the left of this, or are we going to shade in to the right? Now, if we see that, if we were to pick any value, like let's say like x is 1, right? So when x is 1 on this line, well, we want our y values to be greater than that or equal to it. So we're actually going to shade in all the values that are above that. Okay, we want y to be greater. Same thing, if x were to be 2 on this line, doesn't matter what it would end up being, we want it to be greater than that. Y has to be greater, so we're going to shade in this direction. And the same would happen for each of these here. Okay, so graphing, for all of these, right, and so on. So then, so your final look for this would be all of the solutions in this direction, right? And again, we can test a point. I always like testing 0, 0, right? So remembering 0, 0 is right here at the origin. So if I did this right, my inequality should make sense. I should have 0, 0 as one of the solutions. So I'm going to go ahead and do that and put y is greater than or equal to 8/5 x minus 3. So I'm going to substitute 0, 0. So 0 is greater than or equal to 8/5 times 0 minus 3. Okay, so 0 is greater than or equal to negative 3. Is that true? That is true. 0 is greater than negative 3. That works out. Okay, my solution makes sense. It works out, and I shaded on the right side. Awesome. All right, so go ahead and write your summary. This takes a little bit of some time. Anywhere that you missed or you're not sure, go ahead and document that in your notebook, and that's it. Bye.